Welcome back to Java Internals Crashcasts. I'm Sheila, and today we're diving into an intriguing topic within our garbage collection chapter, weak references and memory leaks. Victor, are you ready to unravel this mystery for our listeners?
Absolutely, Sheila. I'm excited to explore this crucial aspect of Java's memory management with you and our listeners.
Great. Before we jump in, let's start with a quiz question for our audience. Here's a tricky one. In Java, which type of reference is most likely to help prevent memory leaks while still allowing objects to be garbage collected when memory is low?
Ooh, that's a great question, Sheila. It really gets to the heart of our topic today. Without giving away the answer, I think this question will make our listeners think about the different types of references in Java and their impact on memory management. It's not as straightforward as it might seem at first glance.
You're right, Victor. It's a bit of a brain teaser. Now, before we delve deeper, could you give us a quick refresher on what references are in Java?
Certainly. In Java, a reference is essentially a pointer or an address to an object in memory. By default, when we create an object and assign it to a variable, we're creating what's called a strong reference. These strong references keep objects alive in memory, preventing them from being garbage collected.
That makes sense. So, if strong references keep objects alive, what exactly are weak references?
Great question. Weak references are a special type of reference that don't prevent garbage collection. Think of them like sticky notes on a bulletin board. They point to an object, but if the garbage collector comes along and needs to free up space, it can easily remove the object without considering the weak reference.
I love that analogy. So, if weak references are like sticky notes, does that mean they can easily fall off or be removed?
Exactly. Just like a sticky note might fall off a bulletin board, a weak reference doesn't keep an object in memory if there are no strong references to it. The garbage collector can reclaim the object at any time, even if weak references are pointing to it.
That's fascinating. But how does this relate to memory leaks? Can you explain what a memory leak is in Java?
Certainly. A memory leak in Java occurs when objects are no longer needed by the application but are still being held in memory by strong references. This prevents the garbage collector from freeing up that memory, causing the application to use more and more memory over time, potentially leading to out-of-memory errors.
Oh, I see. So how do weak references help prevent these memory leaks?
Weak references can be incredibly useful in preventing certain types of memory leaks. For example, let's say you're implementing a caching system. If you use strong references to store cached objects, they'll never be garbage collected, even if the rest of your application no longer needs them. This could lead to a memory leak, but if you use weak references instead, the garbage collector can reclaim those objects when memory is low, preventing the leak.
That's a great real-world example. Are there any other common use cases for weak references?
Absolutely. Weak references are often used in listener or observer patterns to prevent memory leaks. They're also useful in implementing canonicalizing mappings, where you want to maintain a single copy of equal objects without preventing garbage collection.
Interesting. Now, I've heard that there are other types of references in Java besides strong and weak. Could you briefly compare them?
Of course. In addition to strong and weak references, Java also has soft references and phantom references. Soft references are similar to weak references, but are cleared less eagerly, only when the JVM is close to running out of memory. Phantom references are the weakest and are used mainly for cleanup actions after an object has been finalized.
Wow, that's quite a range of reference types. It seems like using the right type of reference can make a big difference in memory management. Are there any common pitfalls or misunderstandings about weak references that our listeners should be aware of?
Great point, Sheila. One common misconception is that weak references automatically prevent all memory leaks. While they're useful, they're not a silver bullet. Developers still need to be careful about how they manage their objects and references. Another pitfall is forgetting that weak references can be cleared at any time, so you always need to check if they're still valid before using them.
Those are important points to remember. Now, as we're nearing the end of our episode, I think it's time to reveal the answer to our quiz question. Victor, would you like to do the honors?
Certainly. The answer to our quiz question is weak references are most likely to help prevent memory leaks while still allowing objects to be garbage collected when memory is low. They provide a perfect balance between maintaining a reference to an object and allowing it to be collected when necessary.
Thank you, Victor. To summarize today's episode, we've learned that weak references are a powerful tool in Java's memory management arsenal. They allow objects to be garbage collected when no strong references exist, helping prevent certain types of memory leaks. We've seen how they're useful in caching scenarios and listener patterns, and we've compared them to other reference types in Java. Remember, while weak references are valuable, they're not a cure-all for memory management issues, and developers need to use them thoughtfully.
Excellent summary, Sheila. In our next episode, we'll be exploring the fascinating world of JVM internals, starting with class loading and linking. It's sure to be another deep dive into the inner workings of Java.
I can't wait, Victor. And to our listeners, thank you for tuning in to Java Internals Crashcasts. If you've enjoyed this episode, please subscribe to our podcast and leave us a rating. Your support helps us continue creating in-depth, educational content about Java internals. Until next time, happy coding.